what connects the raw chaotic power of a lightning storm to the precision of modern engineering. It's a fundamental glitch in the universe: electric charge. Without it, this motor is just cold metal. Welcome to VastVoltage. Let's visualize the invisible. In the vast world of electrical engineering, we start our exploration with understanding the little things around us, such as electric charges. The electric charge is a fundamental property of matter, like mass, representing the degree of electrification of a particle or an object. Electric charges influence how particles or objects interact with each other, forming the basis of electricity and magnetism. From the lightning in the sky to the power in our homes, it's all about the movement and interaction of charges. There are two types of electric charges: positive and negative. Every particle or object has an electric charge or is electrically neutral. The electric charge is quantized. This refers to the principle that the electric charge of any object or particle can only be an integer multiple of the elementary charge E, which is measured in coulombs. This is the smallest freely observable charge. While quarks within particles like protons have functional charges of E, they cannot exist independently in nature. By convention, the electric charge of an electron is negative, minus E, while the electric charge of a proton is positive, plus E. Neutrons are electrically neutral. For example, the electric charge of a system with 3 protons is plus 3E. But when other electrons are entering the system, the net charge of the system is changing. An electric charge generates an electric field, which is a region where a force is exerted on other charged particles or objects. By convention, positive charges serve as the starting points for electric field lines, which extend outward. Negative charges serve as the ending points for electric field lines, which converge inward. The electric field extends in all directions through space at the speed of light. But for clarity, we typically illustrate it with a simplified set of field lines. The electric field lines will extend from the positive charge towards the negative charge, looking like this. The orientation of the electric field lines varies according to the types of charges present. Additionally, there is a repulsive force between these two charges, known as Coulomb's force or electrostatic force. The force is repulsive for like charges and attractive for opposite charges. Coulomb's law quantifies this interaction, stating that the force, measured in newtons, is directly proportional to the product of the charges, measured in coulombs, and inversely proportional to the square of the distance separating them, measured in meters. Think of a light bulb. The further you go, the weaker it gets. So, the force between charges increases with the magnitude of the charges involved and diminishes with the greater distance between them. If a third charged particle is introduced, the force acting on each charge will now be the result of two separate forces from the other two charges. To create a uniform electric field, we place two parallel plates with equal and opposite charges distributed uniformly across their surfaces. This is conceptually similar to a capacitor, a topic for a future video. A charged particle in an electric field will experience a force, resulting in acceleration unless counteracted by other forces. A positive charge placed in an electric field gets pushed along the field lines in the same direction. But a negative charge does the exact opposite. It gets pushed against the field lines, Meanwhile, something electrically neutral, like a neutron, will simply ignore the field and experience no force. In the static scenario, there is no magnetic field generated by the charges themselves. But in reality, every charge or atom is in motion to some extent. And when they move, they create something even more powerful: magnetic fields. This link is the foundation of Maxwell's equations, the heart of electromagnetism. We will decode that mystery in the next video. If you want to master engineering, make sure you are subscribed and comment your thoughts. I am VastVoltage, helping you visualize the invisible. See you in the next one.